Hand data capture is essential for digital human creation. Traditionally, the hand pose and hand appearance are captured separately to achieve their individual fidelities. To boost the efficiency, markerless mocap and synthetic rendering are adopted for the simultaneous capture of both. However, they either depend on a pose estimator trained with laborious annotations, or generate results with lighting artifacts. In this work, we no longer pursue a simultaneous workflow, but explore how to recover the bare hand appearance from marker-contained hand images. We formulate this recovery task as an unpaired image-to-image translation. Our framework first disentangles the bare hand structure from those degraded images, then wraps the appearance of both hand and background semantics on that structure. The former step benefits from the modeling ability of VIT, and the latter is enhanced by training with dual discrimination on both translation processes and translation results. The challenges of this task mainly come from three aspects. First, since degraded to bare data pairs are hard to obtain, this translator cannot be trained using a fully supervised paradigm. Second, in our task, pixel processing varies across semantics. The background and hand foreground in the image need to be thoroughly preserved, and the marker regions need to be replaced by bare hand skin. Based on the above 2 points, the existing unsupervised translator training cannot handle the problem of the source and target images that contain partial structural inconsistencies. To conquer this obstacle, the main contributions contained in this work are as follows. As a whole, we developed a semi-supervised framework that makes degraded images in marker-based mocap regain bare appearance. Before translation begins, a powerful VIT sketcher is designed to disentangle bare hand structure without parametric model dependencies. Its results are later used to compensate for the structural consistency between the source and target. A novel adversarial scheme is further proposed for the translator's training. It promotes degraded to bare appearance wrapping effectively. During our data preparation, not only marker-contained hand images but also object-occluded ones are considered as the degraded source. Although this increases the diversity of degradation, it also enriches the training data available to us. In the first step, our VIT sketcher regards patchwise hand saliency as mask modeling guidance and learns to predict the bare hand structure token from those visual and mask tokens. Similar to MAE, the mask tokens are learnable. It is used to replace the visual tokens with low bare hand saliency. Considering the hand structure map is redundant, a VQVAE is further adapted to tokenize the bare structure prior. Interestingly, when feeding the sketcher's output as the input again, the two outputs should be consistent because the structure map domain is also an image domain. We utilize this elegant property to train our sketcher in a semi-supervised paradigm. Through experimental comparison, we found that this bare structure modeling is more accurate and robust than either template-based or template-free strategies. In the second step, we construct a structure-assisted translator. It learns to wrap different levels of image appearance to the structure mentioned above. However, this wrapping process is not efficient enough in the existing paradigms. So we further propose a novel scheme in a semi-supervised paradigm called dual adversarial discrimination. Initially, a partner domain is synthesized by degrading hand regions of the bare one. It possesses pairwise mapping relationships with the bare target domain and similarity to the degraded source domain. During translator training, data from the source and the partner domain are fed to the translator simultaneously. Continuously, a process discriminator penalizes the source-to-output process, tolerates the partner-to-output process, and encourages the partner to its paired target process. At the same time, a result discriminator penalizes the output from the source, tolerates the output from the partner, and encourages the data from the target. We construct two source domains to evaluate our appearance recovery framework. Marker-contained domain covers a wide range of adhesion markers, including FPHAB with inertial sensors, MHP with gloves, painted hand with painting colors, and 11 cons with various rings. We also collect data containing optical markers. Object-occluded domain refers to the images in which the object occludes the hand, rather than any hand-object interacting images. We sifted the domain data manually from Freehand, Hand Studio, H-O-3D, Core 50, Ego Dexter and Dexter Object. Numerous qualitative experiments prove that our framework can robustly recover photorealistic hand appearance. from diverse marker contained as well as object-occluded datasets. We also adopt FID and KID to quantitatively compare the fidelity of the generated results using our method, and other baselines. This work can be summarized as follows. We propose a semi-supervised framework to recover the bare hand appearance that was initially degraded during the marker-based mocap process. Because of those trustworthy pairs, this scheme is more efficient than most unsupervised schemes. Because of those multimodal inputs, it is more generalizable than a supervised scheme trained only with synthetic degradation. Last but not least, it provides a novel avenue to acquire bare hand appearance data for other downstream learning problems. Thank you for your attention. Please refer to our paper for more details.